Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. How many schedules can a food critic make in visiting 6 restaurants in a city with 11 restaurants? Here, let's try to determine if permutation can be possible to be used in solving for this situation. For permutation to be used, we need to satisfy 2 conditions. Number 1, there should be no repetitions in terms of the selected objects, in this case restaurants. Take note that in a city with 11 restaurants and you are visiting 6, that would mean that once the food critic visits, say for example, restaurant A, then he or she will proceed to the next restaurant and not return to that same restaurant because he needs or she needs to visit 6 restaurants out of 11. So repetition here is not allowed as well. Now number 2, that the order that the food critic will visit the 6 restaurants, if rearranged, then that specific schedule is different from the first. Take note here that if the food critic will visit restaurant A, B, C, D, E, and F, that's a different schedule if he or she decides to visit A, B, C, D, F, and then E. So that means that permutation is really good to be used here. To do that, we need to satisfy the formula for the permutation NPR, where N is the number of objects that are possible. So we have here 11 restaurants, and we have here R, the number of restaurants taken at a certain time, or in this case, certain schedule. You have here 6 restaurants. So that means we are going to have 11 taken 6. Now in your calculator, if you're having one, if you're going to input this, automatically you will get the result. But of course, if you would like to have a complete solution, that would mean you will have here, for this values of your N and R, you will have the formula N factorial over the result here on denominator. Sorry, in terms of the formula, you have N minus R, then you will take its factorial. Take note that factorial notation is a condensed form of multiplying all integers until n. So we have here n times the number before that, n minus 1. So if you have here 11, the number before is 10 because that's 11 minus 1. Then you have n minus 2 until you reach to 1. Okay? So that's the concept of factorial notation. So we will have it here. Our numerator is 11 factorial over your denominator, which is 11 minus 6 factorial. Okay? So we have here 11 factorial over 5 factorial. Okay? Take note that you cannot cancel factorial here because it's a condensed form of this product. So for your numerator, you can write it in this manner. Okay? You have 11 times 10 times 9 times 8 times 7 times 6 until 1. But let's just end at 5 factorial. Okay? Why do we end at 5 factorial if we could still write it until 1? That is because your denominator is already at 5 factorial. So by having it like this, you can cancel that and we don't need to have a denominator which also a product of 5 times 4 times 3 times 2 times 1. So you will have here the result of this 11 times 10 times 9 times 8 times 7 times 6 alone. And that would be 332,640 possible schedules. Okay, that is the total number of possibilities of schedules that a food critic can make. Take note that there's a lot of possibilities because you are taking 6 restaurants only out from 11, and it follows the concept of your permutation because you are talking about schedules and arrangements of the selected 6 restaurants is counted differently when rearranged. So this is how we show the answer for this situation, as we have 332,640 possible schedules. And that's counted in. Talking about getting the luck of the draw. For all in, subscribe now.